Hey y'all, welcome to Miss Clarke's chemistry class. We've been talking about matter, and we are still talking about matter in this video, but more specifically about how to separate a mixture. Mixtures are most often easy to separate. That's what makes mixtures different than pure substances. There are 5 ways to separate a mixture. So the first way to separate a mixture is just manually. So for manual separation, we can use our fingers if the chemical particles are big enough and if the particles are not dangerous. So see, we can separate this mixture with our fingers. Or if the chemical is dangerous, or we're not sure if the chemical is dangerous, we can use forceps. Forceps is just a fancy science word for tweezers. Another way we can separate mixtures is with a magnet. In this third mixture, we have salt, sodium chloride, iron, and sulfur. Now, iron is magnetic, so let's separate the iron out from this mixture. And we see that since iron is magnetic, we're separating that out. Sometimes part of the mixture floats. So if we put our mixture in water, the part of the mixture that floats will float right onto the top, and then we could just screen it off. Filtration is another way to separate a mixture. This is a common setup for filtration. It's for when we've got big particles mixed with really small particles. So if we pour our mixture through our filter paper on our funnel, when the filtrate all drips through, we will have a component of the mixture in the beaker at the bottom, and then there'll be a component of the mixture that's left behind on the filter paper. So if we were able to zoom in on the filter paper, this is what's happening. You see that our mixture has 2 different types of particles in it. The filter paper is able to capture the larger particles, allowing the smaller particles to go through. The smaller particles that go through and that are in the beaker, that's called the filtrate. Mixture separated. If we have a solution and we want to separate the solid piece from the liquid piece, we can do that through evaporation. Now, we use evaporation when our particles are too small for the filter paper to catch, so we can evaporate the liquid away from the solid particles. So here's my saltwater mixture. When I pour it into my evaporating dish and turn on my Bunsen burner, we just boil all the water off, and the salt residue is going to be left behind in the bowl. Evaporation, another way to separate mixtures. Or if maybe our mixture is 2 liquids mixed together, how do we separate 2 mixtures? Distillation. Let's look at that setup. We use distillation as a separation process when we have 2 liquids mixed together. Now, one thing we might not realize, but each compound has its own melting point and boiling point. So we're going to utilize that information. So if we have 2 liquids in a mixture, chances are they're going to boil at different temperatures. So we set that mixture up here. It's being heated up. When the first liquid starts to boil, the steam rises and then the vapor travels through this condensation tube. Cold water is being pushed all around, so it's going to condense our gas vapors back into liquid. Now, eventually, this is going to stop boiling, but there is still going to be liquid here. That's the second component. Now we have the first component here, the second component still here. Our mixture is separated with distillation. Now, another way to separate a mixture is called chromatography. I know that's probably a brand new word for us. Chromatography is when you want to separate the components of dyes. A lot of the times we don't think about different colored dyes or pigments and pens as being a mixture of different colors. Chromatography will separate those out for us. If we see this ink, it looks like black ink. We put it on some chromatography paper and then we put it in a solvent. As the solvent travels up the chromatography paper, it's going to deposit the pigments in order of their weight. The heaviest weight is at the bottom, the lightest weight is up top. So chromatography, another way to separate a mixture. Don't you feel so much better about mixtures? We know how to classify mixtures as homogeneous and heterogeneous. If you've missed that video, go check that out. Now we can even separate mixtures. We are masters at mixtures. If this video helped, press the like button. Don't forget to leave a comment down below, especially if you want me to make a special video for you. Also, you've got to subscribe if you want to see my next video. Okay, y'all. Bye.